Hello, my name is Juan Moreno.
Hello, my name is Miguel Sedano.
My name is Bianca Nerona, and we will be analyzing the acceleration of a freshman. So our main goal is to find whether or not Miguel is able to travel 30 meters in constant acceleration, and if so, what is the acceleration? Oh yeah, and and this is our procedure. So we put two cones 30 meters away from each other in a straight line, and Miguel had to accelerate for the whole line. We used the video and put it into tracker to find our time, position, velocity, acceleration, and put it in Excel to find our graphs.
Before I play the video.
And these are our equations for the xt graph. As you can see, there are two equations for this part. For this first stage, as you can see, it's a little curved, and you can see over here at t squared, it indicates that there's a curve. And here it's more linear, so that's why we have a more linear equation. These are the equations that we relate to our xt graph. Or what?
Then go to the next one.
Our vt graph. And here there are also two equations because there's two stages. Here, this indicates that there's an increase here, which indicates that there is an acceleration. But over here is more stagnant, which means that there is no acceleration, so it's zero here.
All right, so analyzing our xt graph, we could see that at this point, like Bianca was saying, the velocity is going to be positive, right? Because if we drew a tangent line, it would have a incline to the up, and then the acceleration would also be positive since it's concave up. That means that there's an increase in velocity, thus it's going to be a positive acceleration. Over here, however, we could see that velocity is still positive because the tangent line is still going to be with a positive incline, and acceleration is not going to be zero since the equation is sort of linear at this stage of the graph. That means there's constant velocity and zero acceleration. Now, in analyzing Miguel's motion just using this graph, we can see that he's always going to the right since it's always positive velocity. We can see that he never came at rest since there's no velocity equals zero, or in other words, a horizontal tangent. And we could see that at t equals 1, he is speeding up because both his velocity and acceleration are the same sign. And at t equals 4, he is just moving at a constant speed. Okay, so what about the slopes? Let's see, at t equals 1 using Excel, we calculated the slope to be around 3.39 meters per second. How does this relate to the VT graph? Well, we could see that at t equals 1, the value for V is around it's between 3 and 4, so that's a good correlation. Is this just a coincidence, or is this like a kinematic rule? It turns out it's not, 'cause like if we see at t equals 2, the value for V, the slope is 5.8 meters per second, which is also represented in the VT graph. It's just about 5, so that makes sense. Now, showing this for all of the slopes at each second, we could see that at t equals 3 and at t equals 4, the slopes are actually equal. That also proves that there is constant velocity at this stage of the graph. Over here, it does decrease, but that's just that's because of some error in our data collection. And this just goes to prove once again that the slope of the xt will always give you the value of velocity in the VT graph. All right, so what about the VT graph? We could also analyze this by saying, well, from like 0 to 2.5 seconds, the acceleration should be positive. Why? Because this trend, it seems to have a positive incline. And from 2.5 seconds to 5 seconds, we could say that, well, acceleration is around 0, right? Because we group all of these points. You could see like the eclipse somehow forms like a horizontal tangent. Now, we could see that Miguel was always moving to the right. Why? Because for all of the values of t, velocity was always above the x-axis. And you can see the y values, the v values are always positive. And Miguel could also prove that he never came to a rest because none of the velocity touched the x-axis or went below.
Right. So about the area under the curve. So in this example, we have the velocity versus time graph, and we calculate the area under the curve, which should represent my position at that specific time interval, which in this case ends up being 8.2 based off of the one of the kinematic equations. And if we compare that to the position versus time graph, it should equal the exact same thing, which it does in this instance. And this is at 2 seconds and approximately 8.2 meters. Then next up, we have the second stage of my velocity in which my acceleration went down. It still didn't go to 0, but it is almost at that point. That is why it is seen to be more horizontal. In calculating this area under the curve, we end up with 19.2 meters. And that almost matches the calculation we did on the position versus time graph, which ends up being 19.3 meters. Now, combining both areas under the curve, we end up with 27.4 meters. This is, of course, in the velocity versus time graph. And this value should match what we end up getting for the position versus time, which is 27.5. The acceleration, there was a variety of factors that could have screwed up the data, including the fact that running includes a lot of stops with steps and accelerating forward. Not only a tracker, which we had to calculate every single point by every frame of the video, and also the fact that we had to calculate the slope of the position versus time to get the velocity, and the slope of the velocity to get the acceleration. Then this is my this is me versus Usain Bolt, was clearly Usain Bolt is faster than me, but we're both going in the positive direction.
Miguel is not able to travel in constant acceleration because in constant acceleration, though his acceleration is positive, it isn't constant. As you can see here, we have two different accelerations. From 0 seconds to 2 seconds is 1.6 meters per second squared, and we found that using the VT graph by using its slope. And here, 0 to 5, we saw that it was stagnant, so it's 0 meters per second squared. Any questions?
Should we just say, instead of you having to explain that part, should we just say from A equals 0 to 2 seconds